In the context of the National Electrical Code, specifically the 2005 edition, NEC stands for normally open. This term is crucial in understanding the operation of various electrical components and circuits, particularly those involving switches, relays, and contacts. A normally open contact or switch indicates a circuit condition where, in its default or unactuated state, the circuit is open, meaning there is no electrical continuity and current cannot flow. To elaborate, consider a simple switch. When the switch is in its normal, resting position, which is its normally open state, there is a gap in the circuit. Imagine a drawbridge that is raised. Electricity cannot jump across this gap, preventing any devices connected in the circuit from receiving power or operating. This is the fundamental principle of a normally open configuration. Now let's delve into the practical applications and implications of this concept. Firstly, relays are electromechanical switches that use an electromagnet to control a set of contacts. A relay with normally open contacts will have these contacts open when the relay coil is not energized. When a current is applied to the relay coil, it creates a magnetic field that pulls the contacts closed, completing the circuit and allowing current to flow. This is useful in scenarios where a low voltage signal is used to control a high voltage circuit, providing isolation and protection. Secondly, consider safety circuits. In many safety systems, such as those used in industrial machinery, normally open contacts are used to ensure that the system fails in a safe state. For instance, an emergency stop button might be wired with normally open contacts. When the button is pressed, the contacts close, initiating a shutdown sequence. If the wiring to the button is damaged or disconnected, the circuit remains open and the machine cannot be started, preventing potential hazards. Thirdly, in control systems, normally open contacts are frequently used in conjunction with programmable logic controllers or PLC. The PLC monitors the state of these contacts and initiates actions based on their status. For example, a temperature sensor might have a normally open contact that closes when the temperature reaches a certain threshold. The PLC can then use this signal to activate a cooling system or trigger an alarm. Understanding the difference between normally open and normally closed contacts is essential for proper circuit design and troubleshooting. A normally closed or NEC contact, in contrast, is closed in its default state, allowing current to flow until an action, such as pressing a button or energizing a relay coil, causes the contact to open. Using the wrong type of contact can lead to unexpected behavior and potentially dangerous situations. It's also important to note that the National Electrical Code provides guidelines for the proper installation and wiring of electrical components, including those with normally open contacts. Adhering to these codes ensures safety and prevents electrical hazards. For example, the code specifies requirements for wire size, overcurrent protection, and grounding to minimize the risk of fire or electric shock. Consider a scenario where you are designing a lighting control system for a building. You might use a light sensor with a normally open contact to automatically turn on the lights when it gets dark. The light sensor is connected to a relay, and when the light level drops below a certain point, the sensor closes its normally open contact, energizing the relay coil. The relay then closes its own contacts, which are connected to the lighting circuit, turning on the lights. This system provides energy savings by ensuring that the lights are only on when they are needed. In another example, consider a fire alarm system. Smoke detectors often have normally open contacts that close when smoke is detected. These contacts are connected to a central alarm panel which monitors the status of all the smoke detectors in the building. When a smoke detector detects smoke and closes its contact, the alarm panel is triggered, initiating an evacuation sequence. In industrial automation, normally open contacts are used extensively in control circuits for motors, pumps, and other equipment. For instance, a pressure switch might have a normally open contact that closes when the pressure in a system reaches a certain level. This signal can be used to start or stop a pump, preventing overpressurization or other undesirable conditions. When working with normally open contacts, it's crucial to verify their operation with a multimeter. A multimeter can be used to measure the continuity of a circuit, which is an indication of whether the circuit is open or closed. By connecting the multimeter leads to the terminals of the contact and checking the resistance, you can determine whether the contact is functioning as expected. A normally open contact should show infinite resistance when it is in its normal state and zero resistance when it is closed. In addition to understanding the basic principles of normally open contacts, it's also important to be aware of the different types of contacts that are available. Some contacts are designed for low voltage, low current applications, while others are designed for high voltage, high current applications. The choice of contact depends on the specific requirements of the application. Furthermore, the physical construction of normally open contacts can vary depending on the manufacturer and the intended use. Some contacts are enclosed in a protective housing to prevent contamination and ensure reliable operation, while others are exposed for easy access and maintenance. When selecting normally open contacts, it's important to consider factors such as the operating temperature, humidity, and vibration levels in the environment where the contacts will be used. These factors can affect the performance and lifespan of the contacts. In summary, NO, or normally open, as defined in the National Electrical Code, particularly the 2005 edition, refers to a contact or switch that is open in its normal, unactuated state, preventing current flow. Understanding this concept is fundamental for electrical safety, circuit design, and troubleshooting. From relays and safety circuits to control systems and industrial automation, normally open contacts play a critical role in a wide range of electrical applications. Always consult the NEC and other relevant standards to ensure compliance and safe practices when working with electrical systems.